calculators for this. So we know dy dx is x plus y. You can get them. F of 2 is 0. We're going to use Euler's method and a step size of 0.2 to approximate f of 3. Now, usually on the AP test, this would be on a calculator portion, but they're usually on the non-calculator portion, but they give you like 1 or 2 steps. Most of the problems we do are 5, 6 steps, but if it's a no calculator part, they tend to give you just 1 or 2 steps. They say, what would your first step be in Euler's method? It's not how they would phrase it. Okay? So, we're given f of 2. I want to know what f of 3 is. I have no clue what the curve is. I don't know if it's increasing, decreasing, but I know at 2, it's a 0. I want to find what 3 is. Right? Can I take the antiderivative of that? No, because it's in both of x and y is a function, correct? So, I'm going to make a table. Big table. With my point, xy, my derivative, dy dx, delta x, which is my step size, delta y, which is my step size in y, and x plus delta x, y plus delta y. Make sure you have all this written down, nice neat table. Okay. So, my point. I was given the point 2, 0. So that's what I'm going to start with. That's my initial point that they give me. Now, the slope at this point. So I plug them in. What is my slope? 2. Does anyone follow that? My step size, like I said, here I'm told. You don't have to be told. Usually you pick a step size of 0.1 or 0.2 or something close, right? Delta y. Remember, to find delta y, you multiply these two, which will give me, really guys? 0.4. Right? 2 times 2 with a decimal, you wait. Okay, now I want the new point. So x started as 2, it changed 0.2, it is now 2.2, correct? Y started at 0, but it changed 0.4, so you're now 0.4. So there's an example of like the AP test could ask, what would your first step be? The next point. That's the next point. So now I'm going to take that point, and I'm going to do the process all over again. So when I plug those into the derivative, what will I get? 2.6. Delta x is still 0.2. That's my step size. What will delta y be? I got 0.52. Is that all right?
Oh.
Yes, no?
You're right.
And then so my new x would be 2.2 plus 0.2, which is 2.4. My new y would be 0.92, right? So once again, they could ask you, what is the second point you find on the AP test? Second step. That would be an example of a no calculator one. Here it gets a little messier, so we're going to start using them if we haven't already. Okay, so I have 2.4, 0.92 is my new point. So what would my slope be?
3.32.
What do I get?
3.32.
3.32? Delta x still 0.2. 2.2, what will I get when I multiply those? Go ahead and use them. We're trying to get this done. Here. 664. Yeah. So my new x is 2.6. What's my new y?
1.581.
1.581. 4. Anyone else get that?
Yeah.
So now I take that new point, 2.6, 1.584. What will my derivative be? 4.184. What is that? Anyone else get that?
Yeah.
0.2, multiply them. What will I get for delta y? 8368. Anyone else get that? Okay, so my new point is 2.8. What will my new y be? 4 to what?
08.
Don't round. Is it perfect? 08?
Yeah.
Okay, perfect 08. 2.408. Anyone else get that?
Sorry, 4208.
4208. Anyone else get that? Okay, but that actually brings me to a good point. Never ever round this. Ever, ever, ever. Okay? Round Euler's method. Okay? Because that's the whole point. We want to get as accurate as we can. If we round a little bit, it's going to be less accurate. Alright. And you should be thinking, when the heck do we stop? When we get to 3. Okay? Exactly. That's what we're trying to get to. So my new point is 2.4208. What's my new slope?
1.2208.
0.2208.
Yeah.
0.2. Multiply them. What will I get for delta y?
1.04416.
4416. My new point is 3. What's my new y?
3.46496.
Anyone else get that? Okay, so let's answer the question now. This is not enough. F of 3 is approximately, because it's an estimate, 3.46496. So we don't know F, but we know F of 3 is very close to that. Probably, about 3.5 really, when you think about it.